Good morning, evening time zone to all of you on Earth. Is it snowing where you are? It is where I am. It's times like this when I like to just sit back, watch the snow, and sip some ginger ale. Yeah. But some news came to me recently that there's a class action lawsuit going on with pretty much every major ginger ale manufacturer. I looked into it, and as a chemist, I kind of have a opinion and input on this to share, as well as my own ginger ale recipe. So please enjoy this recipe with a little side serving of chemistry. Here's all the equipment I used, and here's the ingredients. First, you measure 2 cups of drinking water and place it in your saucepan. Then, you'll add 1 cup of sugar. I use turbinado sugar here because it has a really full taste and gives a little bit of a yellow amber look, which is what we want. Cut up 1 cup's worth of ginger, leaving the skin on. That equals about 100 grams by weight. Some people take off the skin because they plan on reusing the ginger in some kind of marmalade or something. I didn't bother with that. Place it in the saucepan with the sugar and water. Add just a pinch of salt and 1 teaspoon of lemon juice. Now comes the exciting part. This is food-grade malic acid, also known as DL malic acid, the central point of contention in that class action lawsuit that I was talking about before. Here's what it looks like. Just a fine white crystal. Don't get it in your eyes or any sensitive tissues. Treat it like you would something spicy. Don't worry, it's perfectly safe. You'll want to watch your pot for the first 5 or so minutes, giving it a good stir so that all that sugar gets dissolved. Several minutes later, it's gently simmering. That means the bubbles are rising to the top from the bottom. Here's what that looks like up close. Take your kitchen timer and set it for 45 minutes. Lower the heat to just below medium so that the simmer barely sustains itself, and just let it go. Stir it every 5 minutes or so. Okay, our syrup is simmering, so it's a good time for the chemistry sidebar. What's the deal with this class action lawsuit involving ginger ale manufacturers? You can look up this lawsuit yourself using this information here. The case number, date of filing, and the fact that it is filed out of the United States District Court for the Eastern District of California. Now, the content of this is 9 complaints for violations of various consumer protection laws and laws regarding false advertising. You'll see none of this centers around safety. No one was harmed by this ginger ale, but it is absolutely negligent misrepresentation. Scrolling down a bit, we have point 86 here for both of these products, and this is particularly examining the labeling on Schweppes ginger ale products. Malic acid, actually artificial DL malic acid, is the first ingredient by weight after carbonated water. That means that it absolutely is the primary flavoring in this product. None of the product's front or back labels include the required artificial flavoring disclosures. This is a deliberate omission to be able to claim that they're using natural flavoring, but what's the deal with this? What's the difference between malic acid and DL malic acid? How do they know it's artificial? Well, that's what I'm here to help explain. So here is malic acid, the molecule in question. It can be found naturally in all sorts of fruits and berries, and of course in ginger. That's what makes it a effective ginger flavoring. It imparts that tart sour taste that you may have tasted in candies and green apples and various wines. But it's got something special going on about this particular carbon right here. In these structures, the actual atoms of carbon are omitted, and what you're seeing, these lines here, are actually the bonds between them. So right here, where things converge, that is a carbon with 4 things bonded to it. What's going on with it? First, we gotta talk about carbon. Carbon is an element especially important because it can be found in coals, in the graphite we use as pencil lead, in the organic molecules in our medicines that interact with our body, and all of the plastics and polymers we use, as well as in the bodies of every known living organism. Plants, people, animals, everything relies on carbon. Carbon has 4 valence electrons, meaning there are 4 points about which it can bond with other atoms. You can see those here. Now, when bonds actually form with these electrons, it's not a flat shape like the surface of your screen or the surface of paper. It's something more like this everlasting gobstopper looking thing here, made of balloons, because the actual volumes occupied by these electrons and the bonds that they form do not occur in a 2D plane. They occupy 3D space just like the rest of us. Molecules have 3D shapes. They're not all flat. Now, I want you to take your 2 human hands and face them palms up towards you. And think about it. These are made of the same components attached to the same center, your palm. Yet, if you keep them in the same direction, put your hands on top of one another, keeping the palms up, they're opposite of one another. The relationship between the thumb, the pointer finger, each finger and its neighbors are what we call non-superimposable mirror images of one another. Mirror images that cannot be placed on top of one another. They are not going to form the correct symmetry. Try this with your palms pointed down. Put your hands on top of each other. The pinkies will be pointed in opposite directions. The thumbs will be pointed in opposite directions. This can also be observed in these carbon centers, where 4 things with distinct identities from one another are all centered around the same carbon. A molecule can be either left or right-handed. Sometimes, because of the nature of whatever is producing it, it will prefer the left-handed or right-handed form. It will form them exclusively because the enzymes, the bigger molecules that are engaging in these reactions, have shape. So here we have the 2 forms of malic acid, L-malic acid and D-malic acid. The DL-malic acid, referred to in the class action lawsuit, is a mixture of the 2. You can see that the bond to that particularly interesting carbon is represented differently. On the left, with L-malic acid, we have that thick triangle, meaning that the bond, instead of being flat, is actually pointed out, upward. Once again, think about that everlasting gobstopper shape. And the broken line represents that it is going backwards into the page. Not represented is a spare hydrogen, which is bonded to the same carbon. And in each of these, the hydrogen would be occupying the opposite position. In L-malic acid, the hydrogen is facing backwards out of the plane. In D-malic acid, the hydrogen is facing forwards out of the plane. A situation like this is what we call stereoisomers. They are fundamentally the same molecule, same chemical, but they are different in the geometry of how that group attaches to the structure, which raises a question: how do we acquire it? Can we do chemical reactions to preferentially produce one over the other? L-malic acid occurs naturally in all of those fruits. If you were to extract it from those fruits, which is highly inefficient at the industrial scale, you would only get L-malic acid. When you are forming this using chemical reactions of its constituent parts, you don't really get to pick which side it orients itself to in 3D, so you will get a mixture. This is what we call a racemic mixture when it contains both. Now, if that's so important in the body, is there any danger posed by having both L-malic acid and D-malic acid in a mixture in something you're drinking? No! There is no evidence of danger associated with the racemic mixture of malic acid's 2 stereoisomers. And we know this because chemists have been working with this one since the late 1700s, the very beginnings of what we would call modern chemistry. And it's been used heavily in all sorts of applications in flavorings, the stereoisomers do not taste different from one another, do not perform different from one another in the body. There's no evidence in the couple of centuries that we have been working closely with these molecules to indicate that there is any danger posed by consuming the mixture of the two stereoisomers. In short, is this mixture of DL malic acid, the synthetic flavoring, dangerous to consume? No, there's absolutely no evidence that this is one of those molecules that interacts heavily with the body and where this level of specificity is needed. But was it dishonest on the part of the companies marketing their products as being naturally flavored? Yes, absolutely. Beverage companies misrepresented their products as being wholly naturally flavored. This is evidenced by the fact that D-malic acid was found in there. D-malic acid only arises from synthetic processes. If it was naturally flavored, only L-malic acid would be present because that's the only form that is produced by the plants and vegetables that contain it. But what's the takeaway from this? You can safely enjoy your commercially produced ginger ale without worry, because these companies are now required to make the proper disclosures about the artificial flavoring in them. And this artificial flavoring poses no health risks. It's incredibly well documented. It's a chemical that humanity has worked with closely for a long, long time. It was just really shady of them to claim that this was natural flavoring. Oh, do you hear that? Oh, I think it's done simmering. Let's go. Aha, you thought it was finished, but I'm taking a sidebar for the spiced cranberry variant. At the halfway point of cooking, add half a cup of dried cranberries and a 3-inch stick of cinnamon. I've got one whole piece of nutmeg here, and I've cut off 2 big chunks of it. That'll be easier to filter out. It's kind of tough to do with a knife, but if you don't trust yourself, you can put the nutmeg inside a Ziploc bag and smack it with a hammer or meat tenderizer. Just take big bits. Either way, the leftover nutmeg can be placed back in the jar with all of its brethren. At the end of the 45 minutes, turn off the heat and carefully strain the liquid into a heat-resistant container. Here's that lightly candied ginger that some people use in marmalade and other stuff. I'll be discarding it. Here are the 2 syrups side by side. The spiced one on the right has a little lower yield because the cranberries sucked up some of the water. To turn this into drinkable ginger ale, fill 1 standard drinking cup full of ice. Take your syrup of choice and fill it up to about 1/3 of the volume with the syrup. So less than half. You might want to experiment with this. It turns out a little different every time I make it. That's about 1/3. Okay. Then you'll take your seltzer water of choice and fill it up the rest of the way. Do not use tonic water unless you want that quinine taste. I only ever use seltzer water. Then, give it a mix. Yeah, that passes the sit test. That's ginger ale, all right. There you have it. Making ginger ale is really that simple. I hope some of you give it a try. Let me know in the comments how it turns out. I'm throwing up those recipe cards. Peace and glub, everybody. Peace and glub.